Right.
I don't even see why we're.
All right, so we're just continuing in section 5.4 today. So more sum and difference formulas.
What do you do? Who's grill?
So we're just going to go through a couple more examples of using these identities. So for our first example, we're going to verify use our sum of difference formulas to verify some identities. So we want to verify that the sine of 90 degrees minus x equals the cosine of x. We've talked about this one a little bit before, but now we have a formula and we can verify this identity. So we're going to look at our sheet, our formula sheet, and we have an identity for the sine of the difference of two angles. So the sine of 90 minus x, we're using our identity for the difference of two angles, is the sine of 90 degrees times the cosine of x minus the cosine of 90 degrees times the sine of x. And I can look on the unit circle, or if I remember, the sine of 90 degrees is we're straight up at 90 degrees. The y coordinate there on our unit circle is 1. So this is just 1 times the cosine of x. And the cosine of 90 degrees is the x coordinate on my unit circle straight up at 90 degrees, which is 0 times the sine of x. And this just simplifies to the cosine of x. So I've just verified, use the sum and difference formulas to verify this identity. So we're just using our formula for the sine of the difference of two angles. Questions on that one? All right. We're going to verify a little more complicated identity next. So we want to verify sine of x plus y times the sine of x minus y equals cosine squared y minus cosine squared x. So I'm going to work on the left-hand side. So we're going to work with this, and I'm going to use my identities, my sum formula for the sine of an angle, and the difference formula for the sine of an angle. So I'm just going to rewrite each of these two, using the sum formula and using the difference formula. So I'm going to say that the sine of x plus y times the sine of x minus y. So I'm going to use the sum formula first. That equals sine x times the cosine of y plus cosine of x times the sine of y. That's my first one, using the sum formula. And now I'm going to multiply that with this using the difference formula. So this is sine x cosine y minus cosine x sine y. So I just rewrote this first term using the sum formula, rewrote the second term using the difference formula. Now I'm going to FOIL this big set of parentheses. So I'm going to FOIL this. So for my first term, I get sine squared x cosine squared y. I'm just multiplying sine x cosine y times sine x cosine y. For my outside, I get sine x cosine y times cosine x sine y with a negative sign. For my inside, I get cosine x sine y times sine x cosine y with a positive sign. So those two cancel. So I get a plus something here, and I get I get a minus something here, and I get a plus the same thing here. So those cancel, those go away. They add up to 0. And then for my last term, I get a minus cosine squared x times sine squared y. So that's from multiplying this times this. I get the minus sign from there. Now, what I'm trying to get to, I'm trying to get here, I see that everything is in terms of cosine. And here I have some sines mixed in. So I want to rewrite all my sines in terms of cosines. So I'm going to, because what I'm trying to verify, where I'm trying to get to, is all in terms of cosines. So how can I rewrite sine squared x in terms of cosines? I have my Pythagorean identity that says sine squared x plus cosine squared x equals 1. So sine squared x is 1 minus cosine squared x. Sine squared x is the same as 1 minus cosine squared x. And I still have this cosine squared y minus cosine squared x. And I can do the same thing with this sine squared y. Sine squared y is 1 minus cosine squared y. I'm just using the Pythagorean identity here for sine squared y. Now I'm going to distribute. So from here I'm going to distribute the cosine squared to everything there, and the cosine squared to everything there. So I'm just going to make a note here that I'm going to distribute. So I get, when I distribute, I get cosine squared y minus cosine squared x cosine squared y, distributing there, minus, and when I distribute here I get cosine squared x, and I get a minus and a minus, so that turns into a plus cosine squared x cosine squared y, and I have a minus cosine squared x cosine squared y there, and a plus cosine squared x and a cosine squared y there. So those add up to 0, and I get cosine squared y minus cosine squared x. And we verified that identity. So my first step was to use the sum formula for sine x plus y, the difference formula for the sine x minus y. I FOILed, distributed, and then I got some nice cancellation, and in just a few steps I was done. But this all started from using my sum formula and my difference formula. Questions on that one? All right, I have one last example. We're going to solve an equation. So we're going to solve cosine x plus pi over 4 minus cosine x minus pi over 4 equals 1. So normally our big picture idea when we were solving trig equations is we wanted to get the trig function on one side and everything else on the other. Well, I've got these trig functions, but they're kind of messy because I have a plus something and an x minus something here. So what I'm going to do is rewrite each of these using the sum formula for cosine and the difference formula for cosine. So let me, over here in the margin, I'm just going to write a reminder of what those are. Cosine of u plus v, and this is on our sheet. Cosine of u plus v, cosine u, cosine v, minus sine u, sine v. So I'm going to use that formula here, and the cosine of u minus v is cosine u cosine v plus sine u sine v. So I'm going to use the top formula for this one and the bottom formula for this one. So I end up with, for this one, I end up with cosine x, cosine pi over 4, plus sine x, sine pi over 4. And I'm going to subtract here because I have a minus. And then I'm going to use this bottom formula for what I have here. So this is cosine x, sine pi over 4, minus, let's see. This one, I messed up here. This one should be a minus, because the cosine of u plus v is cosine u, cosine v minus sine u, sine v. So this one should be minus, and this one should be a plus. Plus sine x, sine pi over 4, and that equals 1.
The last part, the second one, the second part of the first part?
Yes. Lots of opportunities to make mistakes here. All right. So the cosine of pi over 4, we can look on our unit circle and find the cosine of pi over 4. This is square root of 2 over 2 cosine x minus the sine of pi over 4 is square root of 2 over 2. Square root of 2 over 2 sine x minus, I get the square root of 2 over 2 cosine x, and I'm going to, instead of putting the 1 down here, I'm going to move it over here. Minus square root of 2 over 2 cosine x plus square root of 2 over 2 sine x. And I get minus square root of 2 over 2 cosine x, or I'm sorry, square root of 2 over 2 cosine x minus square root of 2 over 2 cosine x. Those go away. And I get minus square root of 2 over 2 sine x minus square root of 2 over 2 sine x. This minus turns into a minus here. So I get, and this equals 1. So I get minus square root of 2 over 2 sine x minus square root of 2 over 2 sine x equals 1. The cosine, square root of 2 over 2 cosine x add up to 0, so those go away. So I get minus 2 square root of 2 over 2 sine x equals 1. And the twos cancel here, so I get minus square root of 2 over 2, or sorry, minus square root of 2 sine x equals 1. I want to get the trig function by itself on one side. Divide both sides by the negative square root of 2 over 2. I get sine x equals negative 1 over square root of 2 over 2. And if I rationalize this denominator, what does this equal? Rationalize negative 1 over square root of 2. Multiply by square root of 2 over square root of 2. Sine x equals negative square root of 2 over 2. So I look on my unit circle. Where does the sine of my angle equal negative square root of 2 over 2? I get x equals 5 pi over 4 plus 2n pi. And x equals 7 pi over 4 plus 2n pi. So I look on my unit circle and say, where does the sine of my angle equal negative square root of 2 over 2? And that's at 5 pi over 4 and 7 pi over 4 plus any multiple of 2 pi. So those would be my solutions of this original equation. So I used my sum formula and my difference formula and simplified to come up with my answer. Questions on that one? All right, that's all I wanted to show you today. So the homework, just more practice working with these sum and difference formulas. We have a quiz on Wednesday. Tomorrow we will review. All right, there you go.